Hi algebra students, please find your 10-4 Solving Combined Inequalities notes template. We're going to start off by talking about how we are going to be referencing the words and but to form compound sentences in English, but today we're going to talk about the words and or meaning something in a mathematical context. So let's take a look. The word conjunction is a sentence that is joined by the word and. So that's going to go under conjunction definition. The word is and the symbol is it looks like a capital V upside down. And I think of it like a capital A without the bar horizontally across. For a conjunction to be true, both inequalities must be true. So let's take a look at some examples here. The first example, if we take 4 is greater than 3 and -2 is less than 1, that is true because both of those inequalities are true. 4 is greater than 3, -2 is less than 1. But if I look at the example, 4 is greater than 3 and -2 is greater than 1, flipping that sign this time, because of the second inequality, -2 greater than 1, because that is false, the whole thing is false. So the other case we're going to talk about today, in addition to the word conjunction that we just talked about, is disjunction. And disjunction is a sentence joined by the word or, which means we're going to fill in that the word is or here. The symbol is a capital V. So you'll notice it's the flip of the and symbol. And in order for a disjunction to be true, at least one, that should read 1, of the inequalities must be true. So let's take a look at 2 examples. So for my first example, I'm going to take a look at 4 being greater than 3 or -2 being greater than 1. And because this inequality is true, but this inequality is not true, and we only need at least one of the inequalities to be true, then this example is true because that first inequality is true. But if you look at the second example, 4 less than 3, that's false, and -2 greater than 1, that's also false. And for a disjunction to be false, both of them have to be false because it needs at least one to be true for the whole thing to be true. Just a little review of some of this new vocab that you have. If you look at the first example, -2 less than x and x is less than 3. This is a conjunction and it is joined by the word and. And if you look at the bottom one, y is greater than 2 or y is equal to 2. This is a disjunction and it's joined by the word or. So we're going to jump into example 1 and we're going to look at this first inequality where it says solve -3 less than or equal to x minus 2 less than 4 and graph the solution set. And we're going to do it in 2 ways. Method 1, method 2. And in method 1, what we're going to do is we're going to rewrite it as a conjunction and we're going to use the symbol in between. So I'm kind of separating the 2 mathematical comparisons here. I'm looking at the first one and I kind of reverse the order here. I put x minus 2 greater than -3 because the alligator mouth is still opening towards the x minus 2. So that means the same thing as it did up here in the original inequality. And, here's my symbol for and x minus 2 is less than 4. So I've kind of separated the 2 inequalities, and I'm going to solve that just like I would with an equation, but just keep in mind those rules for dividing or multiplying by a negative when they occur will change the sign. So here on the left, x minus 2 greater than or equal to negative 3. To solve, I want to get rid of the 2 by adding 2 to both sides. So just like I would with an equation, I'm going to show my ALE of plus 2 to both sides. That gives me x greater than or equal to negative 1. And then over here on the right, we've got x minus 2 less than 4. Again, I'm adding 2 to both sides to isolate the variable x. That gives me x is less than 6. And again, there's that and symbol in between. So what I want to do is I'm going to write the solution sets in set braces, and I'm going to use some fancy notation here. I want x such that, so a vertical bar straight up and down means such that x is greater than or equal to negative 1. So I'm just copying that solution that I got with my work into set braces, and x such that x is less than 6. And then I'm going to take a look at the graph. And what I want to do is I want to show you both of the independent pieces separately, and then we're going to graph the whole solution set. So I'm going to differentiate with color. You may want to just make your final graph darker. So let's start by labeling maybe at like negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, and maybe going up to 7. I'm looking at the two values, negative 1 and 6, that I got in my solution sets, and kind of going a little bit below and a little bit above for my number line. So let's take a look at the graph of the first solution set. X is greater than or equal to negative 1. That means that I'm going to have a closed dot at negative 1, and I'm going to shade to the right. And I'm doing it way above my number line because we're going to have a final solution here. And then my second graph, I'm looking at x is less than 6. I want an open circle at 6, shading to the left. And my final graph should be the and statement, the conjunction between these two inequalities. So I'm going to look at what they both have in common. They both go over this point of negative 1, and we have a less than or equal to sign coming at the 6, and then this top graph continues, but the bottom one does not. So that means my final graph for this conjunction is going to have a closed circle at negative 1 because they both had it, an open circle at 6 because that's where the one graph stops and we have to be where they both are, and shading in between. And you'll notice that the and graph is one piece of graph. Now for method 2, I'm going to do the same problem, but I'm going to keep it so that the x minus 2 is in the middle, and I'm going to solve it all in one set of steps. But you'll notice the hint to the side, you must multiply or add to all three parts. And all three parts, I mean on the left of this inequality symbol, in the middle, and to the right. So again, I want to add 2 to get rid of the minus 2 next to the x and isolate the variable, but that means I've also got to do it on the right and on the left. So that will give me negative 1 less than or equal to x less than 6. And if you notice, we're getting the same solution set here that I did on the left with method 1, but my solution set is all one piece and not the two separate solution sets that I had before. And then again, my graph is going to be the same graph. So there's just a repeat of the graph of the solution set of negative 1 is less than or equal to x is less than 6. So moving on to example 2, we looked at a conjunction in example 1. Now we're going to go ahead and solve a disjunction that uses the uppercase V as its symbol and the word or. And you'll notice that it's typed with the word or. Sometimes in the textbook the examples will be with the words, and sometimes they'll be with the symbols, so you need to be familiar with both. So we're going to take a look at solving 2x minus 1 less than 3, or 3x is greater than or equal to x plus 10. So the first thing I want to do is I want to notice that these are two different inequalities, two different steps of work here. So to solve this one on the left, I'm going to add 1 to both sides. And that's going to give me 2x less than 4, and then I'm going to divide both sides by 2. Giving me a solution here of x is less than 2. Or, on the other side, we want to move the 1x over by subtracting x from both sides. That gives me 2x greater than or equal to 10, and I'm going to divide both sides by 2. So, or x should be greater than or equal to 5. My solution set I'm going to put to the right here, it's going to look like this. X such that x is less than 2, or x is greater than or equal to 5. And now we're going to go ahead and graph. Now with an OR graph, what you're going to look at is the one inequality. We have an open circle at 2, and shading to the left, this represents our x is less than 2. And for our second graph, it's going to be a closed circle at 5, shading to the right. And some of you might be thinking, well, there's two pieces of graph, can that be correct? And the answer is yes. A disjunction graph should look like two different pieces here, whereas the conjunction graph was one piece that they had in common, the and. This is an or, which means the x values are either going to fall in this region or in this region, but they can't fall in both. In example 3, we're going to go ahead and look at different graphs of different inequalities, and we're going to come up with the final graph of the conjunction or disjunction that it's describing. And the first decision we have to make in each of these problems is we have to decide whether it is a conjunction or a disjunction, and you'll see that by finding the word and there. So the first graph is on the top. We're looking at x is less than 3, so that's already graphed for you. An open circle at 3 and shading to the left. And then x is greater than or equal to -1. That's graphed for you as well. Closed circle at -1, shading to the right. Now what we have to do is we have to come up with the graph of the conjunction, the and. So we have to look at where they have things in common. So if you look in this region, that's where they have things in common. They both overlap there. And we can definitely use a closed circle at -1 because they both have values at -1. But when you get to the other boundary of 3, the problem is one of the graphs has a hole in it, the top one. It's not equal to 3, but the bottom one is. So because they both have to have it, we can only use an open circle at 3. And then shading should go in between. And you'll notice that I put my final graph on the number line. That's also okay, or you can have it floating above. So take a look at example 4 here. X is less than 3, so open circle at 3, shading to the left. It's already drawn for you, which is kind of nice. Or, so this is a disjunction, closed circle at -1, shading to the left. So we need to figure out the OR graph here. Either one can have it. So the greatest value that one of the graphs has is at 3, but it's an open circle. So we can use that because one of the graphs has it. And then we're going to shade all the way to the left because any of the values from the left of 3 are in either of these two inequalities. So the graph of our OR graph here is actually just one piece. So I want you guys to take a look at example 5. It is a disjunction graph, it's an OR, and I want you to try plotting that on your own and then checking with the graph's answer that will pop up after you answer the question. So go ahead and do that for me. So you should have found that the left inequality, x is less than or equal to -1, was a closed circle at -1, shading to the left. And then the rightmost inequality should have an open circle at 4, shading to the right. For example 6, I want you to draw the inequalities of each of those, or the graphs of those two inequalities way above the number line. Draw the first one on top, second one on bottom, and then we're going to take a look at the graph of all of it. So if you look at the two graphs of the inequalities that I've drawn here, I've got a closed circle at 3, shading to the left for the left inequality, and a closed circle at -1, shading to the right for the rightmost inequality. We're looking at the symbol for OR, so this is a disjunction graph. So basically I need to shade the region of where values would fit at least one of those inequalities. But if you look at this inequality and this inequality both shade the entire number line. So because it's a disjunction, our solution set is basically all reals. It's the entire number line. Because if it fits the top one, it's going to go forever to -infinity from 3. And if it fits the bottom one, it's going to start at -1 and keep going to positive infinity. So you would write an all real symbol next to your graph, and you would also show me on above your number line that you know that this would be all solutions. Everything would work. When you go to graph example 7, the top inequality, or the leftmost inequality, first of all, let's backtrack a little. This is the symbol for and, so we're looking for a conjunction here. The leftmost inequality, we're going to have a closed circle at -1, shading to the right. And for the second inequality, we're going to have an open circle at 4, shading to the right. And we're looking for where they overlap, what they have in common, because it has to fulfill both of the inequalities. And if you notice, they're both going to the right forever, but the least amount is the second inequality. It starts with less than or equal to, or greater than or equal to, pardon me, not or equal to. Oh my goodness. Open circle at 4, shading to the right is what they both have in common at least. The top inequality had all of this leading up to 4, but because it's not in both inequalities, it does not get put in your final graph for the whole conjunction. So our final graph is down at the bottom here. Open circle at 4, shading to the right. So for our last example, when you graph it, you're looking for a conjunction. It uses the word and. We've got a closed circle at -2, and closed circle at 0, shading to the right, and then open circle at -2, shading to the left. And the first thing that strikes me as kind of fishy about this problem is that it looks like an OR graph for an AND problem. And when you're doing AND, you have to find values that are in both, but there's no overlap here in this graph. So this is actually a special case. We looked at all reals for example 6. This is the other side of that coin for special solutions. This would be empty set, and you could write the words no graph, or you could just leave a blank number line on your paper as long as you show me the empty set or the empty set braces, or you could write no solution. Any of those would be good because it tells me that you understand that nothing is in common between these two inequalities. And those are the notes. So make sure that you bring any questions to your math teacher the next instructional day, and make sure that you're also trying these problems on your own for any that you were struggling with when the video was paused.